you're not quite done solving for x squared. No. It's just, yeah. And we need one more measurement, don't we? We need one more. Because if we get one more, we can figure the other two out. Ish, basically. This one, essentially, right? Because if we have that one, we can kind of figure this one.
15.
And we can kind of figure this one based off of these two. So does that kind of make sense? So if we assume this is 30 to 35, and this is 20 to 25, this is either, I mean, it's somewhere around 10 feet, isn't it? But it could be as many as 15, depending on which one of these you use and which one of these you use. See what I just did? If you do 30 minus 20, that's 10. If you do 35 minus 25, that's 10. But if you do 35 minus 20, it's 15. Does that kind of make sense? So we're not in agreement, but I don't want to be in agreement. I want to be estimating. I want to be estimating. The whole point of estimation is we might not agree. But do you see how we're learning from each other as we estimate? How long is it going to take me to run 15 victories? Or 15, how many victories do you run in 15 minutes? I don't know. Estimate, right? Estimate. It's all about estimation. Estimation and refinement. Good! Well, we need this one to get that one, don't we? So what did you, which one did you guys measure? This one? I'm guessing you measured this one. Because once you have this one, we can get this one pretty quickly. So what are we saying for that side wall over there?
I got 15.5.
15, 14, 15.5?
7.5.
7.5.
Yeah.
17. So I heard 15, 14, 15, 17 also? 16. So between 14 and 17-ish, somewhere in there? How's that sound? Okay. So 16 is going to be included in there. So that means if we go low to low, that's 10. That's about 8. And if we go high to low, that's 11, isn't it? If we go 25 minus 14, that's 11. 24 minus 14 is 10. 24 minus 17 is 7. So which we call this right here?
7 to 8.
So 7 or 8. It's pretty tight, isn't it? And the reason that one is so much tighter than this one is because you guys were so convinced this was 24 to 25 over here. I'm down with that.
I called it 9.
7,
I had an 8.
8? Can we call it 7, 8 feet? How's that sound? No. No, not at all. I don't like that at all. All right, friends. We've got estimates of the dimensions of this room. I promise you, sometime this afternoon I'll come there with a tape measure. I'll actually measure the whole damn thing out and calculate the actual, as accurate as I can be, and as precise as my measuring tape will let me be. I'll get the volume for you. We'll see how we do. What I want to do right now is, we know the height's 7. We know the height's 9. Okay, because we actually measured that. How should we calculate the volume of the room knowing that beautiful mess that's up there? I guess I should have put 7, 8 over here.
I think we should just go with what
Like
you
high
said.
to high, low to low, and then the average.
Okay, we could do 3 different. Benji's suggesting 3 calculations. I suggest we do the exact same thing, and you're going to see something that happens because of that. So here's what I want to do. I'm going to break the room into 3 pieces. You 3 rows. You guys right here in these 3 rows. You can work individually or together. This is multiplication, so your choice. You guys figure out using the low ball estimates of all the volume of the air in the room. Okay, okay, with the correct unit. Think about what unit you're going to have for what air is, what the air is measured in. Think about that as you calculate. Okay, and talk to each other about that because it's a unit you probably don't use all that often in your lives. You guys in the next 3 rows, you guys use the high estimates. Okay, so the 35s, the 25s, 25s, and so forth and so on. Fair enough? And the rest of you guys use the mid-range. Use the middle number for each. Fair enough? Have at it, friends. Have at it. And do it any way you want. Although, Ariel, I'm kind of partial to your method over here. Kind of partial to your method. For some reason, it seems like less math, even though it's not. Because if you draw this up, you add 2. And if you draw that out, you subtract 1 from another. So it's still 2 calculations, but for some reason it seems less.
Times 9.
Why would you do times 9?
Oh, yeah.
Can I put a water bottle down somewhere?
So would you do that?
I'm not bringing it.
That'd be like 25.
Oh, I guess it's another one right